we're going to talk about adding and subtracting radicals. And here's the rule. Like if you have, 3 square root 2 plus 4 square root 2, you can add those. It's like this is an apple and this is an apple, like the square root of 2. You have 3 of them, you have 4 of them, you have 7 apples, or 7 square root 2, okay? So the radical part has to be the same, okay? The other thing is, let's say you have something like 4x square root y plus 5 square root y. Well, the radicals are the same, but you can't really add them because this has an x and this doesn't. The only thing that can be different is the coefficients, the numeric coefficient. Okay, so if you had something like 4x square root y plus 5x square root y, those you could add together and you'd have 9x square root y. It's like you're counting them up, okay? All right, so let's see if we have some examples here. So this first one, you have the square root of 12 and the square root of 3, so you're like, oh, well, I can't add those together, they're not the same. But wait, because what is 12? 12 is 4 times 3, and I know the square root of 4 is 2. Now, when we simplify these, you have to be really careful. A lot of times in math, we make a mistake because we try to go too fast. The 5 is on the outside, times the square root of 4 is 2, and then the square root of 3. So see how the 4 is coming out, but when it comes out, you have to take the square root of it, and that's the 2. Okay, plus the square root of 3. Okay, so what's 5 times 2? 10. 10 square root 3 plus square root 3. All right, they're the same radical, so I'm going to get 11 square root 3. And then that one's done. Yay. Now this next one, oh my, that one's a little bit bigger. And it's subtraction. Okay, so we'll just take it piece by piece. Look at the 72. That's 36 times 2. But you can take the square root of 36. All right, so I've got a 20 times 6. I better leave it a little space because I know something's going to happen with those letters. The 2, this 2 is coming right there. Okay, now what about a cubed? That's like AAA, right? So you've got a pair, so 1 on the outside, but 1 left over. And again, you could write AAA, there's the pair, that's the one that came out, and then there's the leftover one. Okay, now, b to the 4th, that's 2 pairs, so b squared. And then the c, that's going to be inside because you don't have 2c, it's just 1c. Okay, so the only thing I can do there is 20 times 6 is what, 120? ab squared, square root 2ac. Okay, now we got to do the minus. We've got the 14. Now what are you going to do with 8? 8 is 4 times 2. You can take the square root of 4, which is 2. And then you've got another a coming out. The b squared's coming out. And then what's left over on the inside? You've got the 2. You've got an a left over, and you've got a c left over. So, just take it piece by piece. You might want to write it out a little more than what I'm showing here. That might help. And you could always write, you just break this whole thing into primes. 2, 2, 2, AAA, B, 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 how many ever B's? Anyway, and circle them up, and you'll know which ones come outside. Okay, minus 28AB squared, square root 2AC. Now, I have to make sure that this part is the same in both of them if I'm going to subtract. AB squared, square root 2AC. Yep, looks the same in both. So now I want to know what's 120 minus 28. 2 from 11, 92. So I'll say the answer is 92 AB squared, square root 2AC. Okay?